Well, good morning and welcome to AP Statistics. Just a reminder, what I collected today was homework assignments 2 and 3 that was assigned well before break. Just wrapping up that loose end. Assignment number 4 is due tomorrow. Tomorrow's review day for Friday's test. This test covers 4 chapters. So if you haven't already read chapters 19, 20, 21, and 22, that is what the test covers. Now, then we have a short unit after that to wrap up the course so that we can then begin our AP review. So the review is 6 weeks, or the test is 6 weeks from Thursday. 6 weeks from Thursday of this week is the AP test. Now, the top row here of the AB80 chart, the 1 proportion Z test, 1 proportion Z interval, that's essentially what we do in chapters 19, 20, and 21. Today we're wrapping up chapter 22, and the second row is the chapter 22 row. We started filling that in yesterday, so we're just gonna wrap that up on your AB80 chart. This is where we left off, the 2 proportion Z interval. And let's start with the conditions. So on the far left, we have these acronyms. And you may as well know what the acronyms stand for. If you look at the back of your AB80 sheet, you see the place to study the acronyms. So let's just go to the back of it briefly and fill in the ones that we know so far. Whenever you see IA, that's the independence assumption. SSA is the acronym for the sample size assumption. Today we're going to get a new one. IGA is the independent group's assumption. And later on we're going to be using normal population assumption. No need to fill these bottom ones in. Like PDA, pair of data, that's for later, that's for the next unit. Okay, so these are the assumptions. That's in the first column. And assumptions are always inherently risky. And so we can never know for sure that an assumption is correct, but we can check conditions so that we feel better about making these assumptions. And that's what the second column is about. Second column is the conditions that we check in order to justify making these assumptions. Assumptions are risky, so we check conditions. Like RC is the randomization condition. 10% C is the acronym for the 10% condition. One of the new conditions that we're going to be learning today that we've never seen before is the independent samples condition. Because we're going to be looking at 2 samples, getting 2 p-hats, p-hat 1 and p-hat 2, and they have to be independent samples. So we're going to check for the first time in our lives today the independent samples condition. And then these last 3 conditions are ones that we do not need yet. So, I mean, some of you are trying to get caught up on or get ahead of the note-taking game, and so you're filling these in even though I'm not asking you to. But these last 3, you do not need to fill in today. Some familiar acronyms in the upper right-hand corner. We have been using RS as the acronym for representative sample and SFC for the success-failure condition. You remember the success-failure condition. We saw it first in chapter 18, where we said that NP had to be greater than 10. That's the success condition. And NQ has to be greater than 10 is the failure condition. The expected number of successes is NP. The expected number of failures is NQ. So that's in the success-failure condition where you check to make sure NP greater than 10, NQ greater than 10, chapter 18. After chapter 18, it's NP hat greater than 10, NQ hat greater than 10. Then once we get into this unit, it's NP sub 0 greater than 10, and NQ sub 0 greater than 10. So those are the acronyms. So now that we have the acronyms, we can flip back to page 1 of the AB 80 sheet and find out what acronyms do we need for finding the parameter, the difference between proportions. I mean, by the way, where might this come up in the real world? When might we ever care about P1 minus P2? P1 minus P2 could be an issue when you're wondering, things like, well, what's the proportion of Americans who want to see Donald Trump reelected? That might be P1. And the proportion of Mexican citizens who would like to see Donald Trump reelected. Are they the same? Is there a difference to 0, or is it non-zero? So the null hypothesis would be that 0, there's no difference. And then we'd have to gather evidence to find out, or to draw the conclusion that the difference in proportions of citizens who would like to see Donald Trump reelected is non-zero. I mean, it is either 0 or non-zero. In fact, it's probably not exactly 0, but we assume that P1 minus P2 is 0 unless we get sufficient evidence to conclude otherwise. So that's a sort of real-life question that's at stake. What's the difference between proportions from two different populations, two different independent populations? So keep that in mind as we examine the conditions. So these two samples, we're going to sample some Americans and sample some Mexicans in that particular situation. Okay, so IA, the independence assumption. We've seen this before. We need to get a random sample of Americans and a random sample of Mexicans. Or American citizens, Mexican citizens. Obviously, some Mexicans are American citizens. Now, or if it's not random, at least it should be representative. Okay, so these conditions we've seen before for checking the independence assumption. Now, sample size assumption. The 10% condition squared means we need to look at the 10% condition for the sample of American citizens and the 10% condition for the sample of Mexican citizens. So there's more work here, twice as much work. We have to check it for both. I have to make sure the sample is not too big. Also, sample can't be too small. The success-failure condition has to be checked for both the American citizens and the Mexican citizens. Okay. Now, here's a new one. We have to assume that the groups are independent of each other. The independent groups assumption. Well, what condition do we check to make sure that that assumption is justified? The independent samples condition is really not something that you check mathematically. You just have to think about it. You know, are these two samples independent of each other, or are they somehow connected in a way that they shouldn't be? Like if we're sampling members of the Donald Trump fan club in America and sampling members of the Donald Trump fan club in Mexico, those would not be independent samples. That would not satisfy the independent samples condition. Wait a second. Yeah, some are from Mexico, some are from America, but they belong to the same fan club. They're getting the same literature. These are not independent samples. So that would be an example of a violation of the independent samples condition. So we have some new conditions to check. Now, got to be able to build a P-trap, and this is going to be a lot of new button pressing. You're going to be thinking, oh, how do I do this? How do I get the answer? You put the B in AB 805624. It's been a while since Zoe has heard the rhyme, so when I say go in unison, I'd like us all to chant/sing in unison the AB 80 chant. Let them hear you in the library. Whoa. Here we go. Ready? Go. AB 805624. CD, the short version. Donate your car today. 8, 2, one more time.
AB 805624 CD. Donate your car today. 82!
I can verify that you were audible in the hall. I could hear you. I wasn't even in the room. I could still hear you.
Yeah.
Laudable. So there we have it. So as you're going through this, it's like, oh, we're doing I like to build a D track. D is for difference. The difference between the proportions of American citizens who would like to see Donald Trump reelected and the proportion of Mexican citizens who would like to see Donald Trump reelected. So D is the difference between those two. If you want to capture the true difference, you build a D trap. Want to capture true proportion, you build a P trap. The true difference, a D trap. The calculator builds a D trap for you by putting the B in AB 805624. Even though you've never done it before in your lives, let's press Stat Test B to build a D trap. So, hey, there he is. Yes?
Do you mind if we take some B-roll footage in here?
B-roll footage, you're welcome to take B-roll footage. So this is WA TV is present taking footage for B-roll. So yeah, I'm just going to keep going here.
B in the
It's right while we're let's give them some quality B-roll footage. So ready to go, class. AB 805624 CD. Donate your car today. 82. That's what I'm talking about. So let's put the B in AB 805624 by going to your calculator and pressing Stat Test B. Here we go. Stat Test B. And sure enough, that takes you right to a 2 proportion Z interval. Now, and remember, quality B-roll always includes a shot of the A-roll. This is the A-roll right here. So, if you wanted to, at some point, if you wanted to come up and take video of the video of...
Oh my gosh.
It's up to you. It's your call.
Of the video?
Far be it for me to tell you how to do your job.
Right. We wouldn't tell you how to do yours.
So suppose we have a sample of Americans that suppose that 23 out of 99 Americans want to see Donald Trump reelected, and suppose that 4 out of 308 Mexicans want to see Donald Trump reelected. Suppose those are our 2 samples. Now, it could be that the differences between these 2 samples are just due to NSV, natural sampling variation. It could be that the proportions in the 2 countries are identical. Could be, but these samples just came out a little bit. And suppose our confidence level, these came out to be fairly different. But suppose we want to be 95% confident that the true difference is between the teeth. So notice that when you press calculate, you get some interesting information. Notice that 0 is not between the teeth. The hypothesized difference between the 2 proportions is 0. 0 is not between the teeth. So this instantly tells us that since 0 is not contained between the teeth, that we could reject the null hypothesis that the difference in the proportions is 0. Oh, by the way, they did the division for you. According to this sample, our sample proportion, P1 hat, 23% of Americans in our sample want to see Donald Trump reelected. Only 1% of the Mexicans in our sample wanted to see Donald Trump reelected. So, and by the way, the sample difference would be about 22%. Notice how 23 minus 1 is 22. No surprise that 22 is the center or the average of the 2 teeth. Make sense? So our sample difference is 22%. What's the standard deviation? The calculator calculated that for you, knowing that N1 was 99, N2 was 308. What is the calculator doing? Well, it's following this formula. By the way, in case you're wondering, something has just gone terribly wrong. Oh, we're back. So here is how the calculator is calculating the teeth for this 2 proportion Z interval. First of all, it took 23% minus 1% to get 22%. So that's the center of the interval. It takes the difference of the 2 proportions, and then it calculates a Z star just like we did before. That Z star for a 95% confidence interval is just going to be your inverse normal of 0.975. So it did inverse normal of 0.975. And yogurt day. Variances add. Even though we're subtracting, variances add. How do you find a variance? You'd take the standard deviation and square it. That's why there's no square root over p hat, p1 hat, q1 hat over n1. Because it's a variance. We took the standard deviation and squared it, so the square root went away. The other variance is p2 hat, q2 hat over n2. So this one was, I think, 99. This one was 308. So that's what you would have to set up. I guess I could even draw. I wonder if this will let me draw. So this was, p1 hat was it 23 over 99 minus, how many was it out of 308?
4.
So it's 4 out of 308, plus or minus. This is always 1.96. And I don't recommend that you mess up your really classy looking AB80 sheet with this specific example, but I'm just trying to illustrate for you how the calculator took the numbers that we typed into stat test B and turned them into 2 teeth. Teeth on the left, teeth on the right. Oh, by the way, this is a quantity. It's this quantity, 22%, plus or minus 1.96. And then it took this fraction again. I mean, what is this? This is 23 over 99. Q1 hat would have to be, what's 99 minus 23? 99, 89, so it's 76. 76 over 99, all over 99, plus 4 over 308 times 300. 4 over 308. All over 308. I mean, that's what it did. And you would have to write that down, but you wouldn't actually have to type in this mess into your calculator. You would just press stat test B. So it's really important that when you say the chant, you got to go AB80. Those are the traps on the left. AB80 is the traps. 5624, those are the tests where you generate a p-value. So AB80, those are the traps where it either contains or does not contain the hypothesized value. 5624 generates p-values which are either less than 0.05 or not less than 0.05, or less than alpha level or not less than alpha level. And then CD is chi-square test. We'll learn that later. Those other things come later. But yes, question. Yes, Nick.
So my question is, what is the Z interval means? What does the interval represent?
It's the, so you're basically asking how to interpret it. And in today's examples, we're going to learn how to interpret the interval. But essentially, it gives you a 95% confidence interval. What we're going to be able to say things like, based on this sample, based on these 2 samples, we are 95% confident that the difference in the proportions of American citizens and Mexican citizens who want Donald Trump to be reelected is between, blank percent, blank percent. Looked like it was about 9% and 30%. So we're just trying to capture the true difference in proportions. And so that's a precursor on how we're going to interpret the confidence interval. So, I mean, it's still going to be a BOTS script. BOTS based on this sample for 95% confidence, but it's just going to have the word difference plugged in there so that people understand what we're talking about. Okay, so that's the lesson. Now for the examples. By the way, we're just wrapping up this unit so that we can review it tomorrow and test it on Friday. Okay. So, and oh, good morning, welcome. Ha. Thanks for coming. Alrighty. Now, go to the 8.10 handout. Now, I'll be honest with you, I can't even remember whether I gave you this handout, but it should look something like this, part 1 of 2.
No.
Did I give this to you? Comparing two proportions, part 1 of 2. Let me just pause the camera while I get you a copy of that. We're back. So new formulas, we already wrote those down. Just write C, A, B, 80 sheet. Okay, so we wrote those down already. New formulas are there. Let's just throw the Donald Trump example up here real quick. Suppose P1 hat was it 33 out of 99? Wait.
23.
Just 23 rounds.
23 out of 99? Okay. Yeah, just trying to keep it connected to the real world. 23 out of 99, that was, or you could even say P sub A for America. P hat sub M for Mexico was 4 out of 308. Are you kidding me? Is that what it was?
Yeah.
Wow. Okay. So that was P Mexico hat. So then the if you want to build trap, it would be P A hat minus P sub M hat plus or minus that quantity plus or minus Z star times the square root of P hat America Q hat America over N sub America plus P hat Mexico Q hat Mexico over the number in our Mexico sample. So then you would have to show the specific numbers in the setup, which was 23 over 99 minus 4 over 308 plus or minus 1.96 because it's a 95% confidence interval. 23 over 99, 76 over 99. Probably a good idea to put those in parentheses, all over 99. That's the variance for the America sample. The variance for the Mexico sample would be 4 over 308 times 304 over 308 over 308. And I mean, that's not too hard to write down. I mean, that's basically the given information. Then you just look at what your calculator gave you, and you can say that that's, in fact, I'm just going to drag this into my document, see if that works. Woo! Still works. And like, I mean, it happens a lot, use it every day, but I'm just thankful every time. Just like when I was walking on the bottom of the Caribbean Sea, every time I took a breath, oh, I was so thankful that my scuba gear was working. It's like, I could breathe, so close to death. So, very thankful that the calculator is still working. So then, I mean, what you do is, you say, okay, friends, this is 0.13519, comma, 0.30348. There it is, that's confidence interval. So that's how we're going to be doing this. Now, in our first example, revealing information, 886 randomly sampled teams were asked which of several personal items of information they thought it okay to share with someone they had just met. 44% said it was okay to share their email addresses, but only 29% said they would give out their cell phone number. Okay. A researcher claims that a two-proportion z-test could tell whether there was a real difference among all teens. Explain why that test would not be appropriate for these data. Too often, friends, we try to rush into doing statistical work without taking time to check the conditions. Hello, it is not appropriate for these data to do a two-proportion z-test. I'll be giving you some blank copies of the AB80 sheet tomorrow so you can practice filling it in and quizzing yourself on the conditions. Why they're not from independent groups. It's the same, you can't take one sample and get two p-hats, like p-hat 1, p-hat 2 out of the same 886 people. No, you take 886 people for the question about email addresses, and then take a different sample for the question about cell phone numbers, and then subtract. The independent samples condition has been violated, so we have no basis building a two proportion Z interval, or a D trap for short. We have no justification for building a D trap and attributing any significance to it. So that's just a heads up right up front. You've got to check the conditions before you launch the rocket or build the trap. Okay, next. Next one. This is a little bit for you to fill in this time. So, dogs and cats that bite people. Ooh, we're continuing with the theme of getting attacked by animals. It's been going for weeks now. On a particular planet inhabited by humans, of all people, authorities believe that the proportion of dogs that bite humans is equal to the proportion of cats that bite humans. Researchers contacted more than 25,000 humans in 2 independent random samples on this planet. So we're taking 2 samples, as we should. See if they had been bitten by a particular animal. And 11,169, or about 88.1% of the 12,678 humans in the first sample had been bitten by a dog. That's a lot of biting going on this planet. About 10,578, or 84.9% of the 12,460 humans in the second sample indicated a cat had attacked and bitten them. I don't mind being attacked by a cat, but I just don't want to be bitten by it. Are the assumptions and conditions necessary for inference satisfied? So on Friday's test, you might have to write out an essay that's organized like this. Well, the randomization, yeah, we're going to assume the samples are representative of all humans. They didn't say it was random. Did they say it was random? Oh, it does say. Yep. Once it says random, then that means representative, so we're good to go with that. And yeah, so independent samples, both samples were drawn independently of each other, so we're good. 10% condition. Yep, success, failure, certainly large enough. We don't know how many total are in the sample, but we're assuming there's a lot of people. So they didn't tell us capital N, but we're going to assume, even though the samples are very large, we're certainly not large enough for the methods of inference. Should not be. It's certainly large enough for the inference of methods, for the methods of inference to be used. Okay, let's keep going. Create a 95% confidence interval. Okay, so since the conditions have been satisfied, we'll find a 2 proportion Z interval. And notice how we fill it in first. You're allowed on the AP test to use meaningful subscripts. So you can avoid writing the phrase, let p-hat dogs represent the proportion of the sample that were bitten by dogs. If you write a full word here instead of just a number 1, then it will be meaningful. So it's p-hat dogs minus p-hat cats plus or minus Z star p-hat dogs, q-hat dogs over number of, that shouldn't say sample 1, that should say number in the dog sample, n sub dogs, AP graders will say that means what you want it to mean, n sub cats. So now try to fill in the numbers, and then go to your calculator to do the rest. So fill in the numbers by hand, go to your calculator, stat test B. I'm going to pause the camera while you do the details. So even though we did not write down the null hypothesis, it would have been that in fact, just for deepening your understanding, go ahead and write a null hypothesis here. That P, not P hat, but P dogs, the true proportion people bitten by dogs minus the true proportion of people bitten by cats is 0. Not p hat, but and then h alternate. Get that right. Hypothesis alternate is that the true proportion people bitten by dogs minus the true proportion of people bitten by cats is, in this case, there's no reason to go greater than or less than, so we just say, well, it's not 0. There's an actual difference here. That's the industry standard, by the way, for alternate hypotheses is just not to use a greater than symbol, less than, but actually just the does not equal to symbol. How many of you on stat test B on your calculator came up with 2.4% and 4%? Somewhere between 2.4% and 4%. That's good, because that's what it should have come up with. The numbers that you have to write down, there's not much math involved in that. You knew the 1.96 was coming. These proportions, p hat 1, p hat 2, are provided by your calculator when you do stat test B. Or you could have written them in fraction form. And here's all these nasty looking fractions. But once you write them down, you just go to the calculator, and then it's time to interpret. So friends, the interpretation is a BOTS statement, B-O-T-S. Based on this sample, we are 95% confident that on the planet studied, the proportion of people bitten by dogs is between about 2.4% higher and about 4.0% higher than the proportion of people bitten by cats. So it's kind of tricky to navigate the use of the English language here. By the way, had this number come out to be negative 0.024, then we would have said between about 2.4% lower and about 4% higher. That would have been a does contain the hypothesized value, therefore fail to reject. Had one been negative, the other been positive, then zeros between the teeth and it would have been fail to reject. But because 0 is not between the teeth, it's not a negative 0.024, it's a positive 0.024. Both words are higher than, or both are higher links up with positive, and we would end up rejecting the null hypothesis that there's no difference, and we would say there is sufficient evidence to conclude that the proportion of dogs that bite people is not equal to the proportion of cats that bite people on this particular planet. So, question, does this provide strong evidence that people are more likely to be bitten by dogs than by cats? Explain. Since the interval for the difference in proportions of people bitten by dogs and cats does not contain 0, there is strong evidence that people are more likely to be bitten by dogs than by cats on this particular planet. All right, so let's flip to the other handout that I've given you. We built a D-trap. Now, let's conduct. Instead of constructing a D-trap, we're going to conduct a hypothesis test. You always have the option of performing inference by either constructing a confidence interval or conducting a hypothesis test. So, last handout, here we go. 8.11. Oh, do you want to see the other one again? This one right here? If you don't have it yet, just take a picture. Kennedy, question.
Why is it that it's strong evidence because it doesn't contain 0? Did I miss that?
Well, if the interval would have been from a negative number to a positive number, then the hypothesized value of 0 would have been contained in the interval. Do you remember that worksheet that we did before break?
Got it, okay.
Where if the hypothesized value is contained in the interval corresponds to fail to reject, but not contained in the interval corresponds to reject the null hypothesis. Okay? So, yeah, Lewis.
Is it possible like 2.4 lower and about 4.0 higher.
Yeah, if this number would have been negative,
Oh, so it's possible that.
yeah, sometimes you get both negatives, sometimes a negative and a positive, sometimes both positive.
Okay. Thank you.
Okay? All right, so on the other handout, 8.11, the problem that we're looking at here, oh my goodness, yeah, it's Ronald's video clip. Comparing two proportions, you knew this was coming, teen smoking and or vaping. Teen vaping, once again, they make us study these worldly topics. I don't know about this. What's the agenda here? Teen Smoking Part 1, a Vermont study published in December 2001 by the American Academy of Pediatrics examined parental influence on teenagers' decisions to smoke and or vape. If you just want to cross off the word smoke and write vape, I mean, that's fine with me. I'm not going to be personally offended, but that you would be messing with reality because that's not what actually happened in Vermont back in 2001. A group of students who had never smoked were questioned about their parents' attitudes towards smoking. These students were questioned again 2 years later to see if they had started smoking. So what we're looking at, and Andrew and Kenny, if I can have your attention, I know it's just kind of stressful learning this. Maybe you want to go and, I mean, actually, it'd be best just to stay here and deal with the stress. Just stay in touch with reality and understand that we're examining whether parents have any influence on teenager decisions. That's what's going on here. When parents say, oh, smoking, bad idea, does that matter? Does it cause people to reverse psychology? You say, okay, well, I don't know what I'm going to do. I wasn't going to smoke before, but now that I know that smoking is going to make you angry, Mom, I'm going to go and do it. Or is it going to be, oh, my mom doesn't want me to smoke. My dad frowns on smoking, so I'm not going to do it. That's what we're studying here. The null hypothesis is that parents have no influence whatsoever on what teenagers do. Just like we assume the drug has no effect on treating the disease. So, by the way, this is a prospective observational study. The null hypothesis is that the proportion of teen smokers, and you can jot this down here, you got a lot to write. The proportion of teen smokers among the group whose parents disapprove of smoking is the same. Tell you what, to save time, just write it down in this form, preferably this form right here. So, P disapproving, that they're disapproving of smoking, minus the proportion of smokers among those with lenient parents, LEN, is 0. You assume that there's no difference in the proportion of smokers between those groups. For the alternate hypothesis, we have to think here, and the thought is that the disproportionate, rather those who disapprove, that would cause there to be less smoking than those who are lenient. So we'll just wrap this up here at the beginning of class tomorrow, but attempt assignment 4. I'm going to post the notes on this so that you can finish the example on your own if you want. So you are dismissed. We'll see you tomorrow.